All right, Gertz. Gertz, ladies and gentlemen, and Bowser?
No, not yet.
What robot is this?
It's not yet ready.
This is not yet?
Not yet ready to go.
Oh, okay. You're telling me it's not yet ready to go. Okay, well, I got something ready to go here, and it's the Nito Pyros. And I should be generating a map. I don't see my map generating. I'm driving it remote control. Yeah, this robot's named Marvin. And some of us have been involved in a class, Intro to ROS, Robot Operating System. I have for years driven this robot around. I maybe have mapping after all. Bear with me one moment. I hesitate to try and plug it into there because my resolution always disappears. Bear with me. So there's a group of us that meets at the SIG, and we're learning ROS. And one of the things we've done, you see me drive this around for years with a laptop velcroed to the top. Hey Cam, how you doing? All right. And but what I've done is I've displaced the laptop with a Raspberry Pi, thanks to Wayne and your Ubuntu Ubiquity group image, and Ralph and the BotVac node. Wayne, good job. If you follow the instructions 1, 2, 3, 4 and don't leave out any of the lines or anything, you probably have success. And so, yeah, I left out a bunch of package installs. And something else I learned is, those SD micro adapters you get for the micro SD cards. If you're using the high capacity micro cards, HDSC and so forth, be sure and get the adapter for the high-speed cards, because that was a lot of my stop and start, besides leaving out the line of packages that I was supposed to install. Hang on a second, I'm going to get the mapping going on here, and I'm going to drive it around. Hey, so Gertz, are you ready yet?
No pressure.
Yeah.
Is that an affirmative?
Yes.
Okay, let me load G-mapping. I'm just going to drive my robot around and maybe end up with a map. But why don't you go ahead and, what do you got here, Bowser?
Yes.
Bowser, ladies and gentlemen. Are we having fun yet?
So, since the last time I got 2 RoboClaw motor controllers, so that now each of the wheels is PID controlled. So hopefully it will drive better outdoors. And a few years ago I bought this robotics commander that is basically an Arduino with an XB. So I added that as well. So there is one XB in the bot and one XB here. And that is a proof of concept, so that later we can do more interesting stuff through that XB. So right now it is just sending joystick positions. And it is running on the NVIDIA Tegra board, and it is using the RoboClaw ROS driver that I just published, so that other people in the ROS training can pick up and use the RoboClaw.
This is that ROS training I was mentioning earlier.
Yeah, so that's it. Yep.
Which RoboClaws are you using?
So these are 15 amps per channel.
Really? They work good for you? Are you using the encoder part or no?
Yes.
Really? And they work fine?
Well, I've been working for today. And
Sometime I want to know the version number because we had no end of trouble with that.
And then we had a larger RoboClaw, I think 60 amp per channel on our larger robot,
Yeah.
and that was working without problems.
See, a bunch of people had success
Lately
with the 60
also.
amp. We had no success with the 15 amp one. I just wonder if it was us or them. We did find bugs in it that we reported and they fixed.
Oh. Yeah, we also
Are you
reported
using
some.
serial or USB?
Right now I'm using USB, but on the other robot we are using serial.
Okay.
Not much difference there.
Thank you.
All right. Oh, Ralph, ladies and gentlemen.
Pretty much following on from what Camp was demoing, I'm also part of the Intro to ROS class. We have another bot vac down there, and since I already had mine pretty much running, I thought I'd show it rather than having to get Camp set up as well. This works. So the robot's right on the floor, right down the front here.
Can you put it somewhere else?
I can put it in this area because that's what I mapped.
Yeah. Right there.
There it is. Can we get the video? Is that coming up too or not?
That's the NITO. That's the NITO bot vac, ladies and gentlemen.
Available at retailers.
Yeah, Amazon.
So while Gertz was talking there, I was just driving around here, and see this is a map I created of the corner of the room. So this is basically the reference platform we're using as a beginner's introduction to ROS. So it consists of the NITO BB80 base. We have a Raspberry Pi. I'm using the Ubiquity. Wayne and the Ubiquity guys have created a nice image to run ROS on a Raspberry Pi. I've repurposed an old Roomba battery and a voltage regulator, and I have the Xbox controller, and that's all sitting inside the dustbin bay. You can see here, so this is the Pi, the yellow is the battery, the wireless, and there's a little voltage regulator. So it sits in there. This is a LiDAR. So the great thing about the NITO is that they have the actual LiDAR on them. So if I can actually see what I'm doing by looking over here, I can declutter a little bit of this
Yeah.
map. I can't see what I'm doing.
He's got inflated out.
Turn off background maps. Drive, let's see what we get. So you can see this is the map that it created. The yellow is the walls. It's a bit hard to see, but as I'm driving, you see the robot is updating on there. There's some flickery yellow, which is the laser scan. It's kind of lost behind the yellow of the map. But once you've done the mapping that we ran, and then running in navigation mode, so I can tell it go to, click on the map over here, and it should do it. It'll be slow.
Motion.
Yep, so the robot's starting off, and it should drive itself over to the point that I clicked to on the map. The Wi-Fi is one thing you'll find with ROS. It really likes nice fast Wi-Fi, and I've got my own router sitting on a chair back there, but between the computer here and the robot. Anyway, you can play with it later if other people have anything else they want to see.
So would you launch to do that? So is it trying to execute your move command, Ralph?
I think it's just having Wi-Fi problems.
Okay.
Let me just move back here and see if it will pick it up again. Yeah.
Yeah.
Yeah, it's timing, so either the robot's lost the router or if the robot's talking to the router and that's back here again. So, but anyway, sorry, the question was, somebody had a question before that on.
Now that's a beautiful map, Ralph. Did you? How many passes did you take?
That was just what I drove around.
That's
while
just
Gus
one
was talking.
pass.
Yeah. So I have another map I created from my house. The first time I even fired this whole thing up.
Yeah, your map looks a lot better than mine. Actually, it did this area really nicely.
But I mean, so the Nito as a mapping device, and this is the first time one passed around my house. That was the map it produced. So
Wow.
it's actually pretty impressive.
That's impressive.
You can see it over there.
Wow.
You don't have a lot of furniture, do
You can see the legs. You can see the furniture legs. I think it just sees the legs underneath all the furniture. So that's what we're aiming for, to get people up to being able to run robots like this using the Nito. For the advanced users, we're also supporting the Jetson TK1 processor instead of the Raspberry Pi, which gives you a GPU and can handle a lot more vision processing. Or for the really adventurous, come along and bring your own robot and build it yourself.
Bill, for comparison, can we get my map here that I created?
So Ralph, you're loading, what are you bringing up when you start that? Is that your bot?
This is the BB-80 launch.
Okay.
And there's two modes. If you look in the instructions on GitHub, there's a flag in the bring up dash or
did okay
the
up
move
here.
base, and you can say do.
But I was running through a wide open area there.
You create your map, save it, shut down. You change that flag to false, and it should come up with navigation.
I loaded your node, but I just brought up Nito node launch.
You run the BB-80 bot launch on top of that.
And that puts the mux in.
Yeah, and it puts all the marks on the joystick. You may need to, because it actually launches the teleop joystick.
Yeah, I don't
So you
have
may
a
need to,
joystick.
you may need to reconfigure that. There's some notes there on the web.
I was trying to do voice and it was ugly.
Yeah. Yeah. So what, I mean, if you join the SV Ross meetup group, to become part of the group, we've posted the code for all of this and instructions on how to bring all this software up and be working with people. Okay, next.
Ralph,
Excellent.
Sorry?
how long did it take to generate that map?
Just as long as it took me to drive around. So 10, 15 minutes. So I would just, I mean, to generate the map, generate teleop, the robot, and just manually drive it. We're still working on fine-tuning the auto nav. Once you've got the map, then you can, as I was trying to do here, point and click. Tuning the planner and move base is the next level of challenge that we have to sort out. But we're getting
The
there.
next level of fun.
Fun, exactly.
Thank you, Ralph Knox. With Let's Build Robots? Let'sRobot.com. Let'sRobot.tv. Jillian, folks. Fine homebrew robots.
Can I get, is there audio?
Yes,
Okay,
there is.
I see there's a little audio.
Somebody help us out here. We got a Macintosh. Oh, okay, you got video there.
I've got video, and can I play a video?
I believe so.
I have like a 2-minute video. It's so much better at explaining things than I am. Let me, right, did we?
You need to shift it to the screen.
Oh, cool. You're right back.
Okay? She'll be right back. This is wonderful. Very nice work.
Oh, hi, people. In the front row there. Oh, no. Sometimes things get a little funny.
That's usual.
There we go. Okay. Let me see if we get audio. I want to show a video. And hopefully this is the updated video because I can't connect to the internet and these robots at the same time. It's complicated. My name's Jill. Nice to meet people. Oh, there we go. Hi, my name is Julian Ogle, founder of ILO Games and creator of Let's Robot. Let's Robot is a game where anyone from anywhere can collaboratively control a robot via twitch.tv. Each robot has an onboard camera that streams live video to users who can then watch as the robot executes their instructions. Any number of users can come in and join the experience and also issue commands. There is a HUD overlay that lets you know which commands are being executed, as well as letting you know the status of various instruments or hardware located on the robot. Users can type forward to move forward or back to move back, and so on. When the game is live, there are two robots available to play, ILOBot and NinaBot. ILOBot is the first robot. Its frame is made from Legos, and it has an ultrasonic rangefinder. NinaBot is a little bit more advanced and has a gripper that can pick up things. Users can control either robot. We build dungeons or sets for the robots to explore, and we make them out of cardboard or whatever else is lying around. We've set up real mechanical puzzles, boss fights, or head-to-head challenges for the robots to compete. The project is still in the early stages and is very much ongoing. The experience will improve with every stream. We try to stream at least once a month, so that gives me plenty of time to work on technical upgrades. Although sometimes I will hop on to test a thing or two, and I'll let people play with the robots while I'm doing so. If you're interested in checking out Let's Robot, I suggest you follow our Twitter, @ILOGames, or you check out letsrobot.tv to get the links to the robots. You should check it out. Thanks for watching. So my name's Jill. I'm a game designer. I used to be a Disney artist, and then I switched over to making games for a while. And about a year ago, I got into robotics, and I thought about, well, how do I combine video games and robotics in an interesting way? And when I saw some of this Twitch streaming stuff, it sort of made me interested, like all this live video streaming. So I figured, well, there's got to be like a cool interactive way to do some of that. So as the video explained, I've built robots and they live stream to the internet. I actually have them running in a Unity client. So like this video stream, oop. Yeah, I know I'm not connected to the internet. So this video stream is running through Unity. People play the robots, and sometimes like I want to show them. Like I have a bad guy named Robad, and so I can do that. And then he'll pop up, and I have like some good characters that help you in the HUD. Yeah. And then she's all in 3D. I can do some, because I have them running in Unity, I can do some like cool AR stuff. And then like you can get like status updates in the HUD, so like I can change all the lights to any color I want to. Oops. There you go. Now it's in war mode. Lights are red. Why are we? Some funny business going on. Yeah, so I put a sword on it, and I made sure I made sure the sword was in just the right position, so that way when you attacked, you saw it coming down on the screen. So they go and they beat up other robots like that. And then, you know, they move in these discrete chunks. And so as a so yeah, lots of people play these things, and I make up games, and like sometimes we do competitive stuff, and I don't know why the video feed just cut out. And then as a V2, I started working on this new robot, which is based on the Mars rover, and I just got a 3D printer a couple of months ago, so I've been going to town on it. So I didn't know anything about design for 3D printing, but I picked up a CAD program called Onshape, which is free online, and then I made this sort of Mars rover replica, like mini rover. So I designed like a counter-rotating differential gear system, Like, and I didn't know anything like a couple months ago about how to do that. And so like what that does is just like the Mars rover, if you pick up like one side, like it'll make the other side like move. Yeah. It's a rocker, right? So it'll always keep like one wheel on the ground. And I'm going to take the video off of here so I can show you. It's going to be on the floor now because it'll run off the table too easy.
It's a floor bot.
Yeah. And so one of the next things I want to do with my project is I want to take it outside. I designed this whole thing around a big fat battery that's sitting right in the middle of it, so the gear system is built around that. And let me see if I can get it to run a little bit. Yes, I know I have no internet. Thank you. Has to remind me every few minutes because I guess internet's important. And so each one of these wheels steers independently. So I can strafe. I can go one way. I can go the other way. Ah! I can go over feet. That was my goal, to go over some feet. Stop. All right. So yeah, I'm currently trying to get something like this up and running, so I'm in the middle of that, and those are all the things I do, I think, right now. So, thank you.
Looks like a dog. Can it wag its tail?
Microphones?
Well, that's the wire for the battery. It's gonna have more features, like this one will be able to turn its head, and I was thinking of either putting an arm or a ping pong cannon on it. I haven't decided, so we'll see what the users think. Yes.
How do the hubs for the wheels work? How do the wheels turn into those axles?
So I designed because one of my motivations for getting a 3D printer is I was unable to find like wheels that you could buy online where you can put the motor inside the wheel and it fits in there entirely, because like I wanted as much clear space as possible. So it's just a standard off-the-shelf servo, and then there's like a little line, like a little IR sensor that counts spokes for the encoders, and like I'm still sort of working those systems out. So yeah. Any other questions? All right. Thank you. Oh.
The young lady up front.
Yes.
How do you like?
Okay.
How do you like? Where do you go to look at the robot? I think you already said maybe like the.
Oh, let's robot.tv.
Okay.
Yeah. And when they're online, anyone can play with them. Yeah. So yeah, lots of people.
Do you need Unity?
I'm sorry.
Do you need Unity for it since you're using?
No, it runs in the web browser.
Oh, okay.
Yeah. So it just streams video to the web, and then there's a chat room, and there's lots of other people there controlling it. Yes.
What was the CAD program?
Onshape. Yeah.
How hard was it to make the
The gears are very tricky to do. Like I only picked it up quickly because I was a 3D artist and I did a lot of design. So like I think CAD's so far in this whole robotics like adventure, like CAD's been the easiest thing to pick up. So, but I cheated. Yeah. Yes.
How have you been learning how to build these things? You said it's just in the last year, right?
Yeah. So I started. Well, I knew what I wanted to make. So I wanted to, because when I started this, I saw like somebody hooked up like the game Pokemon to Twitch, and then like in about a week there was like 200,000 people all trying to play the same instance of Pokemon, and it was like total chaos. So I was like, I'll try to design an experience that's made for a lot of people. And like one of the problems with robots was like they're very expensive and you can't get everyone a robot. So if you can get a whole bunch of people access to a single robot, like that might be more interesting. Did I answer your question?
A little bit, but how do you, are you reading, I mean, how did you learn how to do that?
Oh, how did I learn? Right, I'm sorry, I totally got sidetracked, yeah. So I started with a kit, so I knew what I wanted to make. I started with a kit. That's actually a Parallax activity bot at the base here. I think I've seen a couple of these like floating around. It's like a version of the Bowie bot. And then like I just figured out how to make a Pi talk to it and give it commands, and then I figured out, like at first I found stuff online for like video streaming, but I've had to like do a lot of optimizations to get the latency down. So now it's pretty, I don't know if you like saw it, it's pretty instantaneous, especially when like you have like not Unity and the streamer running at the same time on a computer that's better than my crappy laptop. So yeah.
Thank you very much, Jillian. Let's Robot.tv.
Let's Robot.tv.
Sounds like fun. So here's Dan and Watson. Watson's back here standing quietly in the back. Anybody has questions about Watson should talk to Dan Alberts here. Does it work with wheeled robots? Walk like a man, him and his partner in crime, Chris Mayer. Chris Mayer has a plea for help, if I'm not mistaken, right?
Well, sort of a plea for help. I don't have a demo to show, but right now I'm working on gathering raw data from a simple 6 degree of freedom IMU. I wanted to find out if anyone has already started on or have written software to integrate the data, just basically to do translation and rotation data. It doesn't really matter. This is an I2C. This is the 6050. So
the InvenSense library, you can download a library from InvenSense that does that.
That'll do the integration?
Well, it'll do fusion and give you a quaternion from the gyro accelerometer from the
Yeah, my goal is to be able to like stand at the podium, walk around the room, and have it know where I am.
I've used that chip on an Arduino using their library.
Yeah.
Oh,
so the
60, their library.
Yeah, I use the 6052, but it only gives you a quaternion, so it's not going to help you with translation.
I'll translate. Well, it gives you the linear acceleration. You can integrate that.
Exactly. So I'm asking if anyone has started on software to do that integration. Or I'll look at that library and see if it already does that.
The integration of that is just
you might think that. Yeah. The mathematics is a little hairy because you have to take into account your current quaternion orientation and fuse that with the accelerometer data. So
Have you looked at free IMU?
free IMU. I will look at that, Invent Science, and if anybody else is interested in helping with the project or has other pointers, thank you.
All right. More robots. Who has a robot to show? Raise your hand now. Oh, Joe.
Oh, no.
Come on down, Joe.
I'll do the challenge next time.
Joe, no. Talk about your robot. Let's see your robot. Joe. There we go.
Oh, you dropped your
This is Sparky.
Yeah. So actually, my wife and I have a company that does educational robotics, and so this one is Sparky. Sparky is kind of what these things would be if you were a teacher and you wanted to just like take 10 of them out of a box and give them to kids, and not have to spend a month with your parent building it together. So Sparky has a little bit of everything. It's Arduino based, so we do Arduino code and drag and drop block software, and they actually work side by side. So as you do the blocks, you see the Arduino code being generated, so you can make a nice smooth transition. Sparky itself, we retail it for $150, and it has 3 different light sensors, IR send and receive. It has edge detection, line following, compass, accelerometer, distance sensor. The head's a servo motor. The wheels are stepper motors, so it actually can be accurate enough to draw out its own name, whatever you want. We have a graphic LCD on the back, so you can read the sensor data in real time. Pretty much just everything you want to do in the little hobby robots, all bundled up into one ready-to-go package. And so we sell these to schools. We're in over 1,000 schools. I just brought it because I thought, you know, people have robots around. That's how kind of people communicate these things.
What's the name of the company?
Robotics, and this is Sparky. So we have them on Amazon. We also do educator discounts if there's schools interested. Or Leonardo based. So we also do Bluetooth, so you can connect via a phone and run code via your phone if you want to do that. There's a drag and drop online JavaScript-y thing that some of the customers wrote. We have a lot of really cool customers that just write all these awesome things for it and post it on the forums. Yeah, and then if you want to get into swarmy stuff, we also sell a radio module, an NRF-based radio module that lets you swarm between all of them. Although if you want to do poor man swarm, we also do IR send and receive via remote control codes, so you can do that too. But yeah, I saw this stuff and I saw like the challenges and stuff, and this is exactly the kind of stuff we have on our website. So we have like tons of tutorials and both drag and drop blocks and Arduino code about how to do stuff like that, like edge detection on tables and the line following back there.
Where are you located?
Outside in Leandro.
Okay.
So we just moved back. We've been living in China for about 2 years in Shenzhen, down the street from the markets if people are familiar with Shenzhen.
Isn't that place just blew up?
Oh no, that's Tianjin. That's way north. Yeah. No, you can actually breathe the air down in Shenzhen, kind of.
Can you spin it on the table?
Yeah. Sorry. Just look at the screens. Yeah. So the Sparky goes around, has a little servo head with the ultrasonic distance sensor that you've probably seen in different projects. Has these little grippers in the front. And then the wheels themselves are stepper motor based, so we don't have encoders on them, but there's not much play in it, so it's extremely accurate. We have a demo online where you can draw out its own name on the back pretty precisely. And we're having more, that's a really commonly requested feature, so we're going to have some software soon where you like draw out something, it'll show on the LCD, and then you can run around with it and it'll draw it out.
Does it move?
Yeah, I don't know what program I have on it. It's kind of been in my backpack for a month. Let's see. Maybe it'll have something interesting.
What kind of battery?
Oh, double A's in the back. Oh, it's actually the drawing program. I think I've got a marker in my backpack. It's a little slow. Yeah.
I guess you.
A couple minutes ago, you said that it's like a good school.
Yeah, so we do for schools. Schools are probably our biggest customers right now. Because you don't have to assemble. I see all the cool robots, especially the kids are building, but it takes a long time to build those, right?
Well, I had my dad do pretty much because I did not do them.
Well, you'll do the next one. That's the important.
I'll try.
Yeah. But yeah, the idea is that if you're a teacher, you don't want to have your classroom of like fourth graders trying to build 20 different robots and hopefully they're all the same robot. You just take it out of the box ready to go, and then when you're done, you get to put it in the closet and take it out next time.
Does it just draw this?
Yeah.
Do you draw or does it draw?
Yeah, we got a little marker that goes in the center.
It's not really cool. A little bit. That's what I want to ask about the blocks.
Yeah, these are just like little 10-cent markers you get up here. Yeah, so it's gonna draw out its own name. So we do drag and drop block systems too. So you can have a second grader have the robot draw its own name before they're drawing out their own name. Probably better penmanship too. Yeah. So it's going a little slow because it's really precise. Again, it's doing the stepper motors. I think it's like 1,000 something counts per revolution. So you can get pretty precise. There's some slop in the wheel, so it's not dead accurate. For a $150 robot, you can just buy off Amazon. It's pretty decent. Looking adorable while it's doing it.
Yeah, it is very cute.
Yeah. We make another one that's a hexapod robot too.
So what is your LCD on the top? Just there.
Oh, it's just showing the logo right now. Can't really angle.
Question.
Oh, yeah.
Since it's drawing something, if you have to like draw a picture for like art class, and you're like, I don't want to do it, they just have the robot.
Yeah.
And then it's like you're doing your homework, but someone else doing it.
It's going to take you 3 times as long to code it, but it'll be totally worth it.
Yeah.
And you'll be like the coolest kid in class, because like, I got my robot do my work for me.
I already have my robot to give us some sort of, well, I don't have it for
Yeah, you're going to get your homework done like 5 times as slow as every other kid, but you're going to do it like the best way possible.
Yeah.
Future engineer.
Can it draw any character, or it's pre-programmed to just move?
So this program that's on it right now, you program it like an Arduino. You know, you plug in, there's a little USB port in the back. So you plug that in and you upload it. So this is just running the program that was on it. But you can, this is just turn motions right now. This one's very simple. This is just, turn right, like 26.5 degrees, right. It's in degrees and centimeters. We're all metric.
You should have a logo interface. Joe.
Yeah.
So that's why it's so precise and why it takes a bunch of programming. So then it goes exactly like it. And imagine the testing.
Yeah.
I mean, it has to be like, that's at least take a month.
So it can, but this one was a Python script that I wrote where you drag in an image and you trace out where it's going to go, and then it generates a script, a movement script based on that. But yeah, we get a lot of requests for people to type out their own names and have it upload. So that's probably something we're going to do fairly soon. We're very, very open. It's just my wife and I. So when we have requests like that for stuff like that, we take that very heavily into consideration and come out with new things all the time. Although we do get people requesting for books so they can program Sparky without a computer, which gets very confusing sometimes in support emails. But we don't do that, unfortunately. Everything's online. We have all these tons of lessons that we have online, and we're constantly updating them. We're adding them to do things like write out people's names, or do extra drawing, or we had one person want a relay race for their classroom, so we threw up a lesson for them.
So you say you've got a block version of the
yeah, so we do, it's called Mini Block.
Mm.
It's done by this Argentinian guy. He's really awesome. He works at Harvard now. And it's very Scratch-like. But as you're doing that, it's showing you the Arduino code that it's generating in real time. And then we're also doing, coming out with our Sparky Arduino software, something called ArduBlock, which again is very Scratch-like, but it's folded right into the Arduino software itself. Both with the idea that we have this Sparky Arduino software. So it's just the Arduino software with a different color scheme, but it has every library already loaded in, all the lessons that we have online already baked into it. So you don't have to go installing libraries and this and that. You just download it, it opens, and then you have every library and every part. And we also explain all the physics behind all the parts too. So you're not just like, oh, well, the robot's working, I don't know how. We explain like how a light sensor works and how a distance sensor works, and like little cute cartoon animations. We figure the kids can either be replaced by the robots or designing them, so yeah. I was gonna sit quiet and just do the challenge next time because I already got a robot. But.
It's Joe with Sparky, ladies and gentlemen. All right. So this is my. This is where I talk about machine intelligence. This is Rodney Jr. Rodney Jr. is smarter than the average robot. He has one sensor. This is a mobility sensor. It senses whether or not the robot's moving. It's a Roomba. They call it a stall sensor, but I prefer to think of it as a mobility sensor. So David Heisman, How to Build Your Own Self-Programming Robot, he describes 3 levels of machine intelligence. Alpha, beta, and gamma. Alpha, basically, as long as the robot's moving, it's happy. And with differential drive, you have 9 possible motion codes, including stop, if you want to call it a motion code. And so in Heisman's 1978 How to Build Your Own Self-Programming Robot, he has alpha level machine intelligence where the robot makes random motions. As long as it's moving, it's happy. When it encounters a stall condition, it does more random motions until it eliminates the stall condition. In beta, it has memory so that when it encounters a stall condition and tries something that's successful, it remembers that. So the next time it's in that motion pattern and encounters a stall condition, it'll try the last successful response. And then finally with gamma, when it encounters a stall condition for a motion pattern for which it has no response, instead of reverting to alpha level motion patterns, it'll try other high confidence level beta responses to see if it's successful before it reverts back to alpha. So without any ado, here's alpha. Here's Rodney Jr. and it's got an Arduino, two continuous rotation servos sandwiched between two acrylic discs. This is the one of the club bugs from years ago. Anyways, I'm going to switch him on, and you'll see him do random motions, and then he should. This is a little different than Heisman. Heisman just had the robot moving. It occurs to me that with the differential drive system, the only two motion patterns with any magnitude are either forward or reverse. And so those are the only two interesting motion patterns. Everything else is just rotating around a point, really. So anyways, switch him on, and with any luck, he'll learn forward and backwards. So here he's doing random motion patterns until he finds something that makes him happy, namely the little wheels going around. You see he's happy when the little LEDs blink. Let's say he stalls here. Should try random stuff until he learns the pattern that eliminates the stall condition.
Now, Rodney, is that a jab at Rodney Brooks, or? No,
David Heisman's book came out shortly before Cheaper, Faster, Better, whatever it was Rodney Brooks was, known for, with the elephants don't play chess, something like that. So, so here, okay, I've got backwards. The real trick is when he learns forward from backwards or vice versa. So there's a forward. Okay, there's a backwards, there's a forward, backwards. It's interesting, he does a back left and then a backwards. But he's essentially got the oscillating back and forth down. So there's now it's going to make a liar out of me. Anyways, we're easily amused, right? It's Rodney Jr. Thank you very much. Okay. So, Madari Damari. Question.
If that's Rodney Jr., then what's his dad?
His dad is the original Rodney from a book by David Heisman, How to Build Your Own Self-Programming Robot. It was published in '78. That really changed my life. When I got into computers in the '80s, I wanted to take it to the nth degree, which is what? It's mobile robots. This is the same thing as your microcomputer, but with eyes, arms, and legs. But see, this is this is called a book. I'm trying to be funny. Here, there's a picture of Rodney Sr. in there. But Rodney Sr. was an 8085 microprocessor controlled device with an 8-bit data bus, 12-bit address bus. You'd set your data, you'd set your address, you punch the load button, you program it 1 byte at a time in binary. After about 5 years of wrestling with this, I finally made his alpha level machine intelligence with a computer with a store-bought PC and a relay I/O card. But fun stuff anyways. Okay, who else has brought a homebrewed robot? Raise your hand.